Question 1 talks about the inverse of two functions, and we know that if two functions are going to be inverses, there's a set rules to follow. And we've got, this is the original function. The first thing you want to do is interchange x and y. So that gives me x equals negative 3y plus 1. Now we're going to solve for the y here. So we take the 1 over first, it's going to be a subtraction. So we get x minus 1 equals negative 3y. Then we divide by the negative 3, and we get x minus 1 over negative 3. If we clean that up, we get x over negative 3 is negative 1/3 x, and then negative 1 over negative 3 is plus 1/3. And you can see that that should be the proper inverse, and the one they've got is different, so therefore the answer is false. Question 2, period of the one they've given there, 2. So you've got 2 sine 4x plus 1, and we know that period equals 360 divided by b, and we know that b is this value here, the 4, so 360 over 4 equals 90 degrees, and we've got a period of 90 degrees, so therefore the answer is, again, false. Question 3. Got the graphs of y equals cos x minus 90 and y equals sine x. Well, the thing you should know is that sine and cos are always 90-degree shifts of each other. So this is a true statement straight away, because x minus 90 means 90 degrees to the left, to the right, sorry. The minus means opposite. And as these two are 90 degrees out of sync, of course we could prove it to each other, we could find some points. If x is 90, we get cos of 0, which we know is 1. If x is 0, then we get cos of negative 90, which we know goes down to 0. And we do the same thing for sine and cos. If we do x is 0, we get 0. And if we do x is 90, we get 1. And therefore they replicate. And you can check that out on the unit circle, both of those. Question 4. And if you look at two functions, f of x and its inverse, f negative 1 of x, what do we know about the two? Well, we know the domain of the function is the same as the range of the inverse. We know the range of the function is the same as the domain of the inverse. We know they reflect in the line y equals x, and we also know that f negative 1 of x, this composite function, will always equal x. So if you were to check it, it would always equal x. And of course the second one here, reflecting the y equals x, is the one the question's asking for, therefore it's going to be true. Question says, one way to graph an inverse is to reflect across the line y equals x. True. Question 5, third term of the iterative statement. They give you t1 equals 3, and they give you that tn equals 2 times 2n minus 1, and that's squared minus 15. Well, the way you read this is the next term, and n minus 1 is the previous term. So all it reads is the next term equals the previous number squared times 2 minus 50. So therefore we know that T2 will be the next term. It'll be 2 times the previous term squared, which is T1, and then minus 15. And 9, 18, so the next term is 3. T3 is going to be 2 times the previous term, which is 3 in here, squared minus 15, and I think you'll find the same answer is 3. And therefore we can see the answer is true because it gives you the choice of saying it's 3. Question 6 says we get given the sequence 18, 13, 8 and 3, the product of the A and D values is 90. Well, the A is the first term, 18, and the difference is what it's going up or down by. Well, this is going down by 5, so negative 5. So the product of A times D will equal negative 90. So this one is false. So question 7 talks about the I value, 9%. So we know that R equals 9. And I is the value of R divided by N, where N is equal to monthly, so N equals 12. So I will be 0.09 divided by 12, which equals 0.0075. So this is true. Question 8, cot x. Well, this is one of our trig features. Cot x does equal cos over sine. And of course we know that tan is sine over cos. And we know that tan and cot are reciprocal. So therefore cot does indeed equal cos over sine. Question 9. Looking for the 16th term, so we're looking for T16. And we've got that Tn equals negative 2 plus 4 times n minus 1. There's the nth term, and we just sub in t equals 16. So we know that T16 equals negative 2 plus 4 times 16 minus 1. 16 minus 1 is 15, so 4 times 15. And then we've got negative 2. 4 times 15 is 60, which equals 58, which therefore is true. And question 10, last one, we've got that prove the identity. The left-hand side says this, and of course all we're going to do is work with one side or the other, try and prove it's the other side. So we've got this. If we square this out, it's like a foil. So we get sin x minus cos x times sin x minus cos x. 2 brackets becomes a foil, so sine times sine is sine squared. Now we get 2 of these things, so they're minus sin x cos x, so we get minus 2 sin x cos x. And then the last 2 terms, cos times cos, is plus cos squared x. And we know that sine squared plus cos squared is 1. So therefore we get 1 minus 2 sin x cos x, which I think you're going to find is false because the question says 1 minus 1 sin x cos x. So question 11, a bit longer these questions. We've got to prove which one doesn't equal tan squared. Well, A is 1 minus cos squared over 1 minus sine squared. and we know that 1 minus cos squared is sine squared, and 1 minus cos squared, sorry, 1 minus sine squared is cos squared. Well, that equals tan squared, so that one, A, is correct. B is sine squared over 1 minus sine squared. And we know that 1 minus sine squared on the bottom there is indeed cos squared. So that one does equal tan squared, and that one's okay. C, 1 minus cos squared over cos squared. And the top 1 minus cos squared is sine squared. So you can see where this one's going to. This one is correct. So we're presuming that the D is wrong. Let's just go to it. D is cos squared over sine squared. We know straight away that that is cot squared. So I guess common sense would have said start with the one that definitely looks wrong, and that would have been D. Multiple choice. D is wrong. So question 12. And question 12 can be a little intimidating because it's not quite sure what to do. If you look at the diagram, we've got a period from 0 to 90. So we know that the diagram has a period of 90 degrees. And that might be the first thing we look for. So if we look at A, which is 3 cos 1/4 x, well, the first thing the graph looks like it's a sine graph. So therefore A would be wrong, but the period straight away would be 360 divided by the 1/4, which is not 90, it's actually 1080, I think it is, 1040, is it? Sorry, 360, 1420, that is. So that's definitely wrong. B is a sine graph, but I think you'll find that the period's wrong, because the period equals 360 divided by 1/4, which is 720 times 2, which is 440. 1440, that one should be 1442. So B is wrong. Sine 3x, again, it's a sine graph, we're okay with that, and the period equals 360 over B, and B this time is 3, so it's 120, that one's wrong, which means that D must be right. 3 sine 4x, again, the period equals 360 over B, and B is 4, which equals 90 degrees. It's a sine graph and it's correct, so D is the answer. Question 13 is an interesting question. So we know that we've got y equals a sine b bracket x minus c plus d, or it could be cos, of course. Y equals a cos b bracket x minus c plus d. So the first clue is the amplitude is 2, so we know that a equals 2. The period of 180, therefore, that period equals 180 will be 360 divided by b. That means that b must be 2. Phase shift of 60 degrees to the right, so C is 60 degrees. And we know that D is up 1, so D equals plus 1. And we take each one after another. We know that A, 2 cos 1/2 x minus 60 plus 1, that can't be right because the B is wrong. We're looking for a B of 2. B, again, is going to be wrong because we've got the wrong B value because we've got 1/2. And x plus 60 means it goes to the left. So there's a couple of reasons why that one's wrong. We've got the B wrong and the plus 60 wrong. C is looking better. 2 cos 2 bracket x minus 60, and that seems to fit all the bill. We'll just do D to prove that that must be wrong, and then we can run our way. And it looks like D could be right, but of course we've got to factor out this 2 inside this bracket here, in here, and you get 2 bracket x minus 30, and then you can see straight away why D is wrong, and the answer must be C. Good question. So question 14. diagram there. Just do a quick, just sketch it out. And we've got 6, 31 degrees, and 15 degrees. And we're trying to find x down here. Well, the first thing we've got to do is find the missing angle. We know that 31 plus 15 is 46. Subtract from 180 and we get 134 degrees. I think that's right, 46. And therefore we can use the law of sines. We know that x over sine 134 equals 6 over sine 31. Red's not a very good colour to read, so get rid of the sine 134 over the other side, so we know that x equals 6 times sine 134 over sine 31. And we can see straight away it must be D. And D is your answer, if you look carefully. Nice and easy. Question 15 talks about reference angles. Well, it is fairly easy to work out reference angles. We know that there's the unit circle, 0, 90, 180. This is the unit circle, 270, and then back to 360 here. And the angle given is 240. Well, 240 is going to be 90. 240 is going to be down here somewhere, and that is 240. Remember, 240 is this angle here. Now, which is the reference angle? Well, the reference angle is this angle here to the horizontal. That's always the reference angle. We're in quadrant 3, so the reference angle equals 240, subtract 180 degrees, and that will be 60 degrees. So we get the answer C. And of course, I've done question 16 and question 15, so this should be question 16. We'll come back and do 15 in a minute. And question 15, of course we're not going to do these in order, are we? It would be too easy. Sec 330 degrees, again it's a unit circle. Question, well, we know that this is the reciprocal of cos, so it's 1 over cos 330 degrees. So if we go to our unit circle by memory, 330 is down here. And if you think about it, this is going to be a 30-degree angle. This is a right angle. So this is the short leg, so this is going to be 1/2. And this is going to be root 3 over 2. The only problem is that the 1/2 is going to be negative because it's going down. So this coordinate here must be root 3 over 2 on the x and negative 1/2 on the y. And we know that cos is the x value, which is going to be root 3 over 2. So we've got that 1 over cos 330 is 1 over root 3 over 2. Divide by a fraction, we flip it and multiply, so it's 1 times 2 over root 3. And if we, which equals 2 over root 3, if we rationalize the denominator now, root 3 over root 3, we get the answer 2 root 3 over 3. And if you look at the answers, they've actually got just the 2 over root 3. So we didn't have to rationalize the denominator, which the answer is therefore C. Perfect. Question 17. We've got the Tn equals 200 times 3 to the power n minus 1. This is a geometric sequence, which it tells you it's a geometric sequence, which is good. And it asks you to find the ratio. Well, if you knew a lot about these geometric sequences, always the number that's being powered up is the ratio. So the ratio is 3. Of course, you could go in and find the first term. If T1, when n is 1, we get 1 minus 1 is 0. So 3 to the 0 is 1. 1 times 200 is 200. And then T200 will be T2. And then we get 3 to the 1 minus 1. 3 times 200 is 600. And of course R, the ratio, equals the second term divided by the first term, which does equal 3. But in the shortcut, it's always the number being powered up here that is the ratio, and 3 is the number being powered up. Question 18, and it gives you this colony explosion, and it tells you that it's a geometric expression, and the population, the initial population is when n equals, it's going to be n equals 1 really, but if you know, again, geometric sequences, this number here is always going to be the initial starting point. So in this case, the initial population, it's basically the first term of the sequence, because the first term is where you start from the base. So 200 will be it. If you subbed n equals 1 in, you get 200 to the power 3 to the 1 minus 1. 1 minus 1 is 0. 200 times 3 to the power 0 is 200 times 1, which equals 200. Question 19. So we've got negative 4, minus 11, minus 18, and minus 25, which is our numbers. And we know that Tn equals T1 plus n minus 1 times d. We know that d is the number it's going up by. T1 is negative 4. And we're trying to find the nth term. So, and d, what's it going up by? It looks like it's going down by 7. So this will be minus 7. So therefore we get negative 4. Multiply that bracket out, we get negative 7n. Going to have to put it in a bracket now, plus 7. Take the bracket away, and we get negative 7n. And then plus negative 4 plus 7 is plus 3. And the nth term, therefore, is negative 7n plus 3. And if you look at your options, it's going to be option C, which is just written the other way around, negative 3 plus 7n. Question 20, we've got the function y equals 3 to the x. So A talks about no x-intercept. Well, let's have a look at the graph of this just to sort of see if we can make sense of this. We know if we do an xy chart, just do a quick graph. They're all very similar, these three things. If x is 0, we know that the answer is 1. 3 to the 0 is 1. If x is 1, it's 3. If x is negative 1, it becomes 1/3. And if you remember where these things work, they're all very similar. So we've got the 0, 1, 1, 3 is there, and then negative 1, 1/3. And the graph comes down, and it asymptotes here. And it has an asymptote at y equals 0. So we go through the options, no x-intercept and no y-intercept, so A is wrong. B, no x-intercept, that's true. Y-intercept is 1, that is correct. C, x-intercept and y, well, there is no x-intercept, so that's wrong. And D, x-intercept is 1, there's no x-intercept. So this has no x-intercept because the asymptote, therefore B must be your answer. So 21, a periodic function is a period of 9. The values of f4 and f9 are 6 and 8. And so what is the value of f51? So this means that all the values f9 as it's periodic will equal f18, will equal f27, will equal f36, will equal f45. But it also means that every other value becomes periodic too. So f4, if you add 9 on, will equal f13. And that will equal f22. And that will equal f31. And that will equal f40. And that will equal f49. F6 will equal F15, add 9 on, will equal F24, equals F33. This is how periodic functions work, F42, and the final one, which is the one we want, is F51. So therefore F6 equals F51, and F6 is equal to 3. So therefore F51 will equal 3.